Before I start this video, let me take 30 seconds to tell you something about Exergic. Exergic is India's most trusted and most experienced institute for online GATE preparation. I am Chandresh Mahajan, founder and chief educator at Exergic. I am an All India rank 37 in GATE Mechanical Engineering, an ex-Indian Oil officer having 7+ years of teaching experience as of now. These are the GATE 2021 Mechanical Engineering toppers from Exergic. You can find their preparation strategy on Exergic's website. To know more about our GATE courses, you can visit our website or contact us on these details. Also, you can download Exergic GATE preparation app from Google Play Store. The link is available in the description of video. So as I have told you earlier that many numericals of theory of machines in many units, not only in a single unit, in many units, are just an application of engineering mechanics. Whatever question you see in theory of machines, they may look complex, they may look difficult, whatever be the topic, but ultimately it's the application of engineering mechanics, the numerical application of engineering mechanics. And in theory of machines, there is a topic of cam and follower. There is a topic of cam and follower, right? This is a topic which scare many students. I don't know why they don't feel confident in this topic. But ultimately, this topic, again, just like other units of theory of machines, is an extension, numerical extension or numerical application of engineering mechanics. Almost all questions of cam and follower we can solve by the basic concepts of mechanics and some basic concept of mathematics. We are going to discuss one such question here of cam and follower, which will look complex initially, but as we go on and solve this question, not only you will learn some of the ways in which you have to approach cam and follower, but I'm sure your confidence will also go up. So have a look at this question. Definitely, if you look at this image, it looks complex, right? But let's read the question and then only we have to make any kind of analysis, right? In a cam and follower mechanism, as we can see here, the crank OA has an angular acceleration of 8 radian per second square. This is the center O, this is point A, correct? So this is OA, this is a crank OA, which you can see is rotating with an angular velocity of omega and angular acceleration of alpha. This is the line from which angle is measured. As you can see, theta is measured from this line and the length is shown as 80 mm. The length of this crank is shown as 80 mm. So here the value has been given. The OA has been rotating with an angular acceleration of 8 radian per second, that is given, and an angular velocity of 4 radian per second. So omega is 4 radian per second, alpha is 8 radian per second square in this direction, which has been shown to us. At theta is equal to 60 degree, when this angle theta is 60, when OA is making an angle of 60 degrees, the magnitude of acceleration of shaft B is how much meter per second square? The magnitude you have to tell, important point to note, of acceleration of what? Of shaft B. So as you can see, this B point is written here and this is the shaft B which it is talking about. Basically, this is part of a cam. A cam and follower system has many small components. So this spring, as you can also see here, this is the face of the follower and this shaft is basically the length of the follower, correct? So basically this follower entirely, how much is going to be? For this entire follower, how much is going to be its acceleration, right? That you have to tell, linear acceleration. B is a shaft. And shaft, as you can see, it is restricted to move in this direction, right? It can restrict, it can move up or down like this. So the acceleration that it is talking about, it is linear acceleration. Obviously, the basic knowledge of cam and follower tells you that. But again, from the unit of the answer also you can know it, that it's meter per second square, not radian per second square, which obviously means that we are talking about the linear motion of the follower. Right? Again, if you look at the question, it is just an extension, a numerical extension of engineering mechanics. So let us first focus on what is known to us. Majority of the things that are known to us in the question are given from CAM, right? Whatever is known to us, theta, omega, alpha, it is known for CAM. And using that knowledge, using that information, it is asking us the information about the follower, right? So if we just focus on this part of the CAM, only on this part of the CAM, and we draw a simple diagram, schematic diagram, where these complexities are not shown, a simple diagram is shown. So this is how somehow it's going to look, right? This line is representing the face of the follower, right? This entirely is a follower. Complexity is there, here simplicity is there. Only the mechanically important lines I have shown here. So basically this is the face of the follower which is going to move up, but here we are mainly focusing on this CAM part. As you can see in this CAM part, O is the center, correct? Theta is the same angle. A point I have shown here, this is the point A. And now if you notice here, this A here is connected again to a roller, right? Which again makes sense that this is going to rotate. This roller will roll accordingly, and that will push this follower up and down. Here if you notice, even in this diagram, the radius of this roller was given to you 20 mm. There's one special note I will tell you. Again, something which I have told you earlier. I'm sure I have told you this in mechanics also and in strength of materials also. But whenever you have been given a circular shape, right? It could be a sphere, it could be a cylinder, it could be a thin disc, or just a circle, and you have been mentioned something about its dimension, like here 20 mm is written, right? So there is a possibility that you misinterpret it as diameter or radius, right? If question has mentioned 20 mm, so clearly 20 mm will either be radius or will be diameter, right? But you have to interpret correctly whether it has been given as a radius or diameter. So in such cases, when you have been shown a clear arrow like this, like here you can see, right? Clear arrow is shown, and specifically it is pointing. If you notice, this is specifically pointing that yes, this is the arrow, its length is 20 mm. So clearly 20 mm is radius here. There should be no confusion in that, because diagram is very much clear that an arrow is shown equal to the length, and then one more line is shown which is referring to the length of this arrow as 20 mm, means radius is 20 mm. But in many situations this will be extended like this, right? Which means that this 20 mm is now representing the diameter. Or simply, if nothing is shown, no such arrow are shown to you, no such lines are shown to you, and it simply writes phi 20 mm. So phi represents diameter. So in such situation also you need to be careful. It may be possible that it will represent the question like this using a single line, and it will mention phi 20. And then don't think that, sir, only single line is written and 20, so 20 should be radius. No, phi is written means it is diameter. These are very small things, right? And they are not as such conceptually related to this topic. But if you know these small things, you will be saved from such blunders. Suppose you know all the concepts but you got the answer wrong, you could not get the desired marks and desired rank because you did such silly mistakes. Obviously it will feel a lot bad, right? If you don't know the concept, then it's different, right? You don't know the concept, what could you do in the exam hour, right? But if you know the concept and knowing everything, if you do such mistake, it will feel very bad. You will not be able to sleep for 2 days, right? So it's better to know all these small things which definitely will improve your marks, improve your accuracy, improve your rank. Okay, so here we can see that this roller is having a radius of 20 mm. And AB, its length 80 mm is known to us. So if we just focus here, since radius can be in any direction, if this is the center, this is also 20, this is also 20, this is also 20, and this is also 20. So in this diagram, I am only focused about this vertical length. This vertical length is how much? It is 20. Why I am only focused on the vertical length? Why not on horizontal length? That I will explain you in few minutes. So here, if I only denote you the vertical length, that vertical length is of 20 mm because radius is 20 mm, correct? Now if I focus on this length here, suppose this is point B, right? B is there, okay, point C. So how much is AC? If you focus on this right triangle ACO, AC is equal to how much? OA cos theta is OC and OA sin theta is AC, right? So OA sin theta, that is equal to AC, and OA is how much? 80 mm. We are keeping the units in 80 only, right? Although if you notice, ultimately it is asking you the acceleration in meter per second square. So you don't have to forget that these units you ultimately have to change. But if I change it here, it will again become 0.08. I don't like decimals a lot. Okay, so I'm just keeping it 80. Later on, we will convert it. So I'm just keeping it as 80 sin theta, right? And how much is theta? Theta is 60 degrees as given to us. Theta is 60 degrees, right? This angle is 60 degrees. So the length of AC is 8 sin 60 degree. Now if I want to know the expression for this y, what is y? Y is representing this entire length from this point O up to this face of the follower, right? O is a fixed point. O is a fixed point. Fixed point as in, obviously it is going to rotate like this. OA is a crank centered at O, but O as such is not going to move up or down or right or left. O is situated at its own point, at its own place, right? So I am using O as a reference for this calculation for the discussion that I am doing currently. So for that, if suppose Y is representing the distance of this face of the follower from the center of motion, then what can I write? I can write, or let me not rub it, only rub this and let me keep this. So y is equal to how much? Y is equal to this length of 20 mm plus AC, which is equal to 80 sin 60. 80 sin 60, right? So the y expression I have got, correct? Now let me tell you, why am I concerned about finding y? Question might come to your mind that suddenly why you started calculating y and suddenly why you started calculating this length. Look, what question is asking you? Question is asking you what is going to be the linear acceleration of B, okay? Linear acceleration of B will be same as the linear acceleration of this flat face. Why? Because this is an entirely single unit. This is an entire follower. Suppose this, my hand, as you can see here, is the flat surface, and this is the rod, this is the shaft of follower, correct? So when it moves up or down with whatever speed or acceleration, that is going to be the same whether I talk about the shaft B or I talk about this face, this flat face of the follower, right? I am trying to find out the linear acceleration of this flat surface. Why? Because whatever will be the linear acceleration of this flat surface will be same as the linear acceleration of this shaft, right? Because it is acting as a single unit, so its speed, its acceleration, all will be same. And why am I choosing the flat surface, not some other point? Why not this point or this point or this point or this point? Why flat surface only? Because flat surface is directly in touch with the cam. I know all the things about cam. I know all the lengths. I know the angular velocity, theta value, angular acceleration, right? So it makes sense that using the center, using the O as the center as the reference, I try to find out that at what acceleration this flat face is going to move. Or if I even more specify it, if in place of this entire flat surface, if I choose just one point, so you can choose just this point, right? This point, how much is the acceleration of this point with respect to this center O? That if I want to find out, what is the best way to do that? If I somehow find the expression of y is this distance, right? And then I try to differentiate it 2 times, that will give me the acceleration. y is telling you the length, right, of the distance of this flat face or this point from O. So if I differentiate it once, I'll get this velocity with which this point is moving, or this flat face is moving, or this shaft is moving. Or if I differentiate it 2 times, I will get the acceleration of this point, or the acceleration of the flat surface, or the acceleration of the shaft B. All of them are going to have the same acceleration, same velocity, right? So this is the funda which I am applying in this question. And on the basis of that, I am trying to solve this question. That is why I am focused on finding this vertical length, the length from O up to this point. Got it? That is why I bifurcated it into this length plus this length, and this length I calculated using OA sin theta. Understood? So y we have, the expression of y we have written so far, and now we will try to differentiate it twice, right? But there is still a catch, still one catch here. If I keep the value of theta as 60 degree, the differentiation will not make any sense. Why? Because this 20, that is fixed. That is fixed means even if I rotate it, even if this theta value becomes 30 degree, even if this theta value becomes 90 degree, still the distance between A and this surface will be 20, because that will be always equal to the radius of the roller. So this is a constant which is not going to change. 80 is also a constant. 80 is OA. That is not going to change. Now OA length will not change. It will just keep on rotating. But theta value will keep on changing. Theta is not a constant here. If I chose to write the expression of y like this, everything is a constant. As soon as I will differentiate it once, I will get 0 as answer, because everything looks constant. But it's not constant. Theta is not constant. Correct or not? So here I will be writing it as sin theta. Correct? I know that I have to find out the acceleration of B when theta is 60 and omega and alpha are known. But as such, theta is not a constant, right? So y is also not a constant. If you increase the value of theta up to 90, from 0 to 90, y will increase, right? So that's how it's going to work. Now, if I am going to differentiate it once, 20 is a constant, it will become 0. If I differentiate this 80 constant, it will stay here. Sin theta differentiation will be cos theta, and theta differentiation will be theta dot. So this expression I have got, and now let me differentiate it once more. Let me differentiate it once more. So y double dash, how much will be that equal to? 80 is a constant, I'll keep it out. Theta double dot or theta dot multiplied by the differentiation of cos theta, right? Product rule. Then cos theta, then double differentiation of theta. That's what we will do. We'll apply the product rule, correct? So its differentiation is going to be minus sin theta, and then again theta will be differentiated, which will be theta dot. This is mathematics. This has got nothing to do with the concept of theory of machine or engineering mechanics. This is pure mathematics, right? Differentiating theta dot cross multiplied by cos theta, correct? So right now we kept this without differentiating and we differentiated cos theta. That's how we got this expression. And now in the second part of this product rule, we will keep this cos theta same, and then we will differentiate this one, which will give us theta double dot, correct? So ultimately this is the expression. Let me clear the other expressions and only show you the relevant one here. So this is the expression of y double dot that I have got, and if I write it more clearly, then I can actually write that one first, 80 theta double dot cos theta, and this is with a minus sign, theta dot square sin theta, correct? And this is y double dot, which, as I told you, is nothing but the required answer, the acceleration of shaft B, because it is the acceleration of the flat surface, because it is the acceleration of this point, right? And now what I need to do in this entire expression, I just need to put the values which were known to me. What are the values which are known to me? Theta is known to me. How much is theta? 60 degrees, correct? Omega is known to me. alpha is also known to me, right? Alpha is 8, omega is 4 radian per second square and radian per second. So this is 4 radian per second and this is 8 radian per second square. Please note, you have to be careful about the direction. Since in this question it did not mention anything about the direction, about the acceleration or deceleration. Rather, if just this arrow is shown with omega and alpha mentioned, so we believe both of them are going to increase in this direction as it is rotating like this. So theta, omega and alpha, all of them are increasing in this direction when the value of theta is 60 degrees. So we know these values now. The value of theta we'll put here 60, 60. What is theta dot? Theta dot is nothing but omega. So this value of omega we'll put here and will be squared. What is theta double dot? It is alpha. So this value of alpha we'll put here. So if this expression which we have here, this expression, if I simplify it even more, then this theta double dot will become alpha and this theta dot will become omega. And now we just have to put the values here. So the answer that you have just got by putting the values is minus 788.513 mm per second square. So if you want to convert it to meter, it will be 0.789 meter per second square. Again, if you read the question, it is asking you the magnitude. So minus sign is not going to come here. This minus sign will not be coming. You will put the answer as 0.789 meter per second square.